Hello, ma'am.
Good evening, sir.
Yes, ma'am. Good evening. So, the last class we completed with the P block elements, the completed chapter. We didn't work the MCQs based on this P block elements. The chapter was done in detail for a long time. We had to take to complete this chapter. We shall work some of the MCQs based on this P block element, and we'll start with the next chapter from the next class. Now, some of the questions, we'll have to learn more number of questions. So we'll try to rush through possibly. A lot of questions are there. Let's see how much we can do today, and then we'll continue with the next chapter in the next class. Now, oxidation state of nitrogen is highest in N3H, NH3, NH2OH, N2H4. Now, if you take N3H as a whole, the charge is a 0. Hydrogen, we know it is +1. Nitrogen, we don't know because it's supposed to find the oxidation state of nitrogen. So we'll take it as X. Since we have 3 nitrogen, we will take it as 3X. 3X is equal to 0. Or 3X will be equal to -1, or X will be equal to -1/3. The charge on nitrogen here is -1/3. If we take ammonia, NH3, as a whole, the charge is 0. Hydrogen is +1. +1 into 3 is +3. Nitrogen, we take it as X, only one nitrogen. So X will be equal to -3. In case of ammonia, nitrogen will have -3 as a charge. We take hydroxylamine, NH2OH. As a whole, the charge is 0. OH is -1. Hydrogen is +1. +1 into 2 is +2. And X, we take it as nitrogen. So X plus 1 is equal to 0, or X will be equal to -1. So in hydrazine, nitrogen has -1 oxidation state, hydroxylamine. The next is hydrazine, N2H4. As a whole, the charge is 0. Hydrogen valency, we know it is +1 into 4, it's +4. And nitrogen, we don't know X. Since we have 2 nitrogen, 2X. So 2X will be equal to -4, X will be equal to -2. The question is, the oxidation state of nitrogen is highest. Which is highest here? The highest amongst this is -1/3. So hence the answer for this question is option A, N3H. The next question, the correct order of oxidation state of nitric oxide, nitrous oxide, nitrogen dioxide, dinitrogen trioxide. Oxidation states they're asking. So oxygen is -2, so nitrogen will be +2. Here as a whole, the charge is 0. Oxygen is -2. Since we have 2 nitrogen, we take it as 2X. So 2X will be equal to 1. Nitrogen will have +1 oxidation state here. Here nitrogen will have +4 oxidation state. Oxygen is -2 into 2 is -4. Therefore, it will be having +2. Here as a whole, the charge is 0. Oxygen is -2 into 3 is -6. Nitrogen, we are finding X. Since we have 2 nitrogen, 2X. So X will be equal to +3. So the question is, the correct order of oxidation states of nitrogen in NO, N2O, NO2, and N2O3. We can say N2O, it is +1 nitrogen. In NO, it is +2. In N2O3, it is +3. And in NO2, it's +4. So the correct order of the oxidation state of nitrogen in these compounds is in option B. The next question, when copper is heated with concentrated nitric acid, Now, we have learned that concentrated nitric acid is an oxidizing agent. It will decompose to give nitrogen dioxide, water, and also we get nascent oxygen. Nascent oxygen, 6 oxygen atoms we have. Since we have 2 here, yeah, now this is 6 oxygen. So since nitric acid gives nascent oxygen, it will be a very good oxidizing agent. So when copper is heated with nitric acid, now the charge on copper is 0 here. There is concentrated nitric acid. When copper is heated with concentrated nitric acid, we get cupric nitrate plus we get nitrogen dioxide and we get 2 moles of water. Copper is oxidized to cupric nitrate with the liberation of nitrogen dioxide. Hence, the answer for this question is option C, cupric nitrate and nitrogen dioxide. The next question, the reaction of zinc with dilute and concentrated nitric acid respectively produces. Now, nitric acid with a dilute nitric acid, the first case is dilute nitric acid. You should remember dilute nitric acid will give nitrous oxide and concentrated nitric acid on decomposed concentrated nitric acid will give nitrogen dioxide, NO2. So remember this. So with dilute nitric acid, zinc will react to form zinc nitrate plus nitrous oxide, giving you 5H2O. With concentrated nitric acid, zinc reacts with concentrated nitric acid. This is concentrated and this is dilute. It reacts with concentrated nitric acid to form the product zinc nitrate plus giving you brown fumes of nitrogen dioxide plus 2 moles of water. See, concentrated nitric acid gives nitrogen dioxide and dilute nitric acid gives nitrous oxide. Remember this for your exams. So the answer for this question option for the fourth one is option A. So dilute nitric acid gives nitrous oxide and nitrogen dioxide, concentrated nitric acid. Therefore, the answer is option A. The next question. In qualitative analysis, when hydrogen sulfide is passed through aqueous solution of salt acidified with dilute HCl, a black precipitate is obtained. On boiling the precipitate with dilute nitric acid, it forms a solution of blue color. Addition of excess ammonia to this solution gives deep blue precipitate of copper hydroxide, deep blue precipitate of complex cuprammonium complex, deep blue solution of cupric nitrate, or deep blue solution of cupric hydroxide and cupric nitrate. Now, when copper sulfate solution into aqueous solution of copper sulfate, if hydrogen sulfide gas is passed into in the presence of HCl, it is a second group basic radical. Copper is present in the second group of the basic radical, which you have not done in your 12th standard. But remember, now what happens is copper will get precipitated as copper sulfide. And it is a black precipitate forming sulfuric acid. This is a black PPT. You can see H2SO4. H2SO4 gets eliminated as sulfuric acid, and we have copper sulfide here. This is a black precipitate. Now, the second part is the black precipitate obtained. It's on boiling with dilute nitric acid. When this black precipitate, copper sulfide, is boiled with dilute nitric acid, when it's boiled with dilute nitric acid, we get cupric nitrate plus we get hydrogen sulfide. You can see these two hydrogen and sulfur gets eliminated as hydrogen sulfide, and we get cupric nitrate. Now, next is it forms a solution of blue color. The blue color is because of cupric nitrate. On addition of excess ammonia. So this cupric nitrate, if you add excess of ammonia, we get a deep blue color. The deep blue color is due to the formation of cupra-ammonium ion. Cupra-ammonium ion. This cupra-ammonium ion is deep blue color. So the answer for the solution, therefore the answer for this question is option B. So remember, this is a lengthy question. You should remember. So deep blue color is due to the formation of the complex cupra-ammonium ion or tetraamine cuprate copper 2+ ion. It's a cationic complex. So IUPAC name we have learned in the chapter coordination chemistry. The next question, on heating, lead nitrate forms oxides of nitrogen and lead. The oxides formed are nitrous oxide, lead oxide, nitrogen dioxide, lead oxide, nitric oxide, lead oxide, nitric oxide, lead dioxide. So lead nitrate, PbNO3 twice. Lead nitrate on heating forms oxides of nitrogen and lead. So that means you get oxides of nitrogen as well as you get oxides of nitrogen, lead. What is this? So when we heat it, this lead nitrate decomposes to give lead oxide, plus it gives nitrogen dioxide and oxygen, lead oxide and nitrogen dioxide. Hence, the answer for this question is option B, lead oxide and nitrogen dioxide. The next question, maximum covalency of nitrogen is 3, 4, 5, and 6. The maximum covalency of nitrogen is 5. So therefore, the answer for this question is option C, maximum covalency. It can have 5 bonds maximum. So therefore, it is 5. The next question, 8th one. A brown ring is formed in the ring test of for nitrate ion. It is due to the formation of brown ring test is the confirmatory test for nitrate ion. So nitrate ion is containing solution plus equally prepared ferrous sulfate solution, freshly prepared solution, ferrous sulfate solution. Along the sides of the test tube, we will add concentrated sulfuric acid. At the junction of two liquids, we get a brown ring. That brown ring is due to the formation of nitroso-ferrous sulfate. Nitroso is NO, nitroso-ferrous sulfate. So this gives you a deep blue color. Now what it is? Now it is FeH2O 5 times NO and 2+. This is the complex which is formed, which gives brown color. So therefore, the answer for this question is option A. The next question, the 9th question. The decreasing order of the boiling point of the following hydrides. Decreasing order of the boiling point of following hydrides. We know that in the nitrogen family, we have nitrogen, phosphorus, arsenic, and antimony, and we have bismuth. So hydrides of nitrogen is ammonia, phosphorus is pH3, arsenic is AS2, ASH3, and for antimony it's SbH3. The decreasing order of their boiling point, that is from the highest to the lowest. Now, in order to understand the highest to the lowest, now ammonia has abnormally high boiling point. Now, we should know that as the molecular mass increases, the boiling point increases. Now, this is the graph. This is boiling point versus molecular mass. Now, as the ammonia has the least molecular mass. Ammonia has the least molecular mass. Now, coming to pH3, next we have ASH3 and we have SbH3. SbH3. Now, these are, as the molecular mass increases, you can see the boiling point is increasing, no doubt about it here. But in case of ammonia, ammonia can form intermolecular hydrogen bonding. In case of ammonia, intermolecular hydrogen bonding is possible. Since intermolecular hydrogen bonding is possible, ammonia shows higher boiling point, exceptionally or abnormally higher boiling point. So you can see ammonia is having higher boiling point compared to ASH3 also. I've written like this. So it means the highest is SBH3, second is ammonia, third is ASH3, and the fourth is PH3, because they're asking decreasing order. So SBH3 is the highest, which is greater than ammonia, which is greater than ASH3, and that is greater than PH3. Hence, the answer for this question is option C. So only ammonia forms intermolecular hydrogen bonding. It is an abnormal behavior. Next, on heating a mixture of ammonium chloride and potassium nitrite, ammonium chloride and potassium nitrate, KNO2, potassium nitrite, we get ammonium chloride. When allowed to react with potassium nitrite, the intermediate compound what we get is ammonium nitrite, NH4NO2, and also you get eliminated as KCl, byproduct gets eliminated. Now this, when we heat it, it decomposes to form nitrogen gas, 2 nitrogen, and also you get 2 moles of water, 4 hydrogen and 2 oxygen, 2 moles of water. Hence, the answer for this question is option C, nitrogen. We get nitrogen gas and also water. Next question, the 11th question. Nitrogen is relatively inactive element because now its atoms have stable electronic configuration. It has low atomic radius. It is electronegativity is fairly high. Dissociation energy of the molecule is fairly high. In case of nitrogen, the molecule, each nitrogen atom is held by 3 bonds, a triple bond. Since we have the nitrogen atoms are held by a triple bond, bond dissociation energy is very high. Bond dissociation energy is very high. Therefore, it is relatively inactive. So since there is triple bond between nitrogen atoms and nitrogen molecule, the bond dissociation energy is extremely high. Therefore, it is fairly inactive. Therefore, the answer for this question is option D. The next question. Nitrogen combines with metal to form nitrates, nitriles compounds, nitrites. Now, for an example, if we take magnesium, and if this magnesium is heated with nitrogen, we get Mg3N2. This is called as magnesium nitride. So, any metal, when it's heated with nitrogen, we get metal nitrides. So therefore, the answer for this question is option D, nitrites. The next question. Nitrogen is used to fill electric bulb because it is lighter than air. It makes the bulb to glow. It is not supporter of combustion. It is non-toxic. Nitrogen is not a supporter of combustion. So in the electric bulb, the filament will get heated to a high temperature. If we have oxygen, it can burn. So therefore, to avoid the combustion, nitrogen is filled in the electric bulb because it is a non-supporter of combustion. The next question, which of the following compound will not give ammonia on heating? Ammonium sulfate will give ammonia on heating. Urea, this is urea which on heating gives you ammonia. Ammonium nitrate on heating gives nitrogen gas and water. We learned it in the previous questions. So these 2 nitrogen atoms combines to form nitrogen gas and you get water. Ammonium chloride also gives you ammonia on heating. So which of the following compound will not give ammonia on heating? It is option C, ammonium nitrate. 15th question. Which of the following factors would favor the formation of ammonia in Haber's process. Haber's process principle, you should remember, nitrogen and hydrogen in the ratio 1:3 is heated in a preheated catalytic chamber. Therefore, the product ammonia we get with an exothermic reaction, with the liberation of energy. Now, the condition is iron oxide is used as a catalyst. This is a catalyst. And they use potassium superoxide as a promoter, or we use molybdenum as a promoter, or we use Al2O3 as a promoter. And the temperature is around 500 degrees Celsius and the pressure is 200 atmosphere. So this is the condition, or this is the principle for synthesis of ammonia. So therefore, this reaction in Haber's process, the pressure is very high, 200 atmospheric pressure. Temperature is also very high. Here they mentioned low temperature, but they mentioned high pressure. Hence, the answer for this question is option A, high pressure. The next question, which oxide of nitrogen is obtained on heating ammonium nitrate at 250 degrees Celsius? Ammonium nitrate, the molecular formula is ammonium nitrate. It's NH4NO3. Now, if you observe this equation, on heating, this has to decompose. So now we have 4 hydrogen and 3 oxygen. So 4 hydrogen can react with only 2 oxygen to form water. So 2 into 2 is 4 hydrogen and 2 oxygen. So the third oxygen is there. The third oxygen will react with this 2 nitrogen. Therefore, we get nitrous oxide. So ammonium nitrate, on heating it at 250 degrees Celsius, it will decompose to form nitrous oxide, giving you hydrogen. Hence, the answer is option B. The next one, which of the following oxide is anhydride of nitrous acid? Nitrous acid formula is HNO2. This nitrous acid, we can write like this, HNO2. This 2 hydrogen will react with one of the oxygen atom and to get eliminated as water. 2 hydrogen and one of the oxygen gets eliminated as water. Now, what else is left out? We have 2 nitrogen and we have 3 oxygen because one reacted already with water. 3 oxygen, N2O3. N2O3 is the anhydride of nitrous acid. Hence, the answer is option A. Now, coming to the next question. A gas X is obtained when copper reacts with dilute nitric acid. Now, when copper reacts with dilute nitric acid, what happens? We learned this equation. Copper on heating with dilute nitric acid. We get cupric nitrate plus 3 moles of cupric nitrate plus nitric oxide, NO, plus you get 4 moles of water, nitric oxide. The gas thus formed reacts with oxygen. This nitric oxide, which is formed with oxygen, gets oxidized to form nitrogen dioxide. This nitrogen dioxide is a brown fume. This nitrogen dioxide is a brown fume. That is why this nitrogen dioxide dissolves in water in the presence of oxygen to give nitric acid, 4 moles of nitric acid. This is Z, nitric acid is Z. So therefore, the answer for this question is option A, NO, NO2, and HNO3. So therefore, the answer for this question is option A. The next question, the 19th question. Nitrogen dioxide and sulfur dioxide have some properties in common. Which property is shown by one of these compounds, but not by the other? They form acid rain. Nitrogen dioxide and sulfur dioxide forms acid rain. Nitrogen dioxide and sulfur dioxide act as a reducing agent. Both nitrogen dioxide and sulfur dioxide is soluble in water. It is used as a food preservative. Sulfur dioxide is used in the manufacturing. SO2 is used in the manufacturing of sodium bisulfite. The sodium bisulfite is a preservative. But nitrogen dioxide is not used in order to prepare any preservative. So the property which is shown by one of these compounds, sulfur dioxide, shows the manufacturing of preservative, but not nitric acid. Therefore, the answer for this question is option D. The maximum bond angle at nitrogen is present in which of the following? So remember this, NO2 is a compound, the hybridization and the bond angle. NO2 hybridization is sp and the bond angle is less than 120 degrees. NO2 minus, it is sp2, the hybridization, and the bond angle is 115.4 degrees. And NO2 plus, it is sp, it is linear, and the bond angle is 180. And NO3 minus, the hybridization is sp2, and the bond angle is 120. Now, the maximum bond angle at nitrogen is present in which of the following? The answer is option C, NO2 plus. Since it's a linear molecule, it has the bond angle 180 degrees. The next question, which of the following fluorides does not exist? NF5, PF5, ASF5, SPF5. Which of the following fluorides do not exist? Nitrogen do not form pentahalides because they do not have vacant d orbitals. So NF3 is possible. NF5 is not possible because nitrogen do not have vacant d orbitals. Since it does not have vacant d orbitals, it will not form NF5. So this fluoride, NF5, does not exist, but all the other fluorides exist. The next question, which of the following bonds will be more polar? Which of the following bonds will be more polar? NClOF, NF, N double bond, N and N. The polar character arises due to difference in electronegativity. The electronegativity difference between N and F is maximum. The electronegativity difference is maximum between N and F. So it is a more polar bond. It is N and F. The next question. Are you following? The number of electrons shared in the formation of nitrogen molecule is number of electrons. Number of electrons shared in the formation of nitrogen. Nitrogen atomic number is 7. The electronic configuration is 1s2, 2s2, and 2p3. It has 5 electrons in the outermost orbit. We can represent 5 electrons like this. And here also 5 electrons we can represent. Now these 6 electrons are shared to form a covalent bond. So totally 6 electrons are shared in the nitrogen molecule. Hence, the answer for this question is option A6. Next, aqueous solution of ammonia consists of H plus ion, OH minus ion, NH4 plus ion, NH4 and OH minus ion. So ammonia, when dissolved in water, nitrogen has a lone pair of electron. It will give H plus and OH minus water. It will give a pair of electron to NH4 plus, H plus. Therefore, we get NH4 plus and OH minus. So aqueous solution of ammonia will contain NH4 plus and OH minus. Hence, the answer is option D. The next question. Pure nitrogen is prepared in the laboratory by heating ammonium chloride, with sodium nitrite. When ammonium chloride and aqueous sodium nitrite are heated, nitrogen gas is liberated with the water formation and sodium chloride gets eliminated as a byproduct. And 4 hydrogen and 2 oxygen gets eliminated, 2 moles of water, and these 2 nitrogen atoms combine to give nitrogen, pure nitrogen. Hence, the answer for this question is option D. Now, coming to phosphorus, we will learn some of the questions based on phosphorus. I think a lot of questions we learned with nitrogen, few questions with phosphorus, and then we will keep on. The atomicity of phosphorus is 1, 2, 3, 4. What does it mean? Phosphorus exists as P4. Nitrogen exists as N2. Sulfur exists as S8. So we learned. So phosphorus exists as P4. The structure of white phosphorus is square planar, pyramidal, tetrahedral, trigonal planar. So white phosphorus, it has a tetrahedral structure. It has a tetrahedral structure with bond angle around 60 degrees or something we learned. So the answer for this question is option C. The structure of phosphorus, white phosphorus, is tetrahedral. Each of the following is true for white and red phosphorus, except that they are both soluble in carbon disulfide, can be oxidized by heating in air, consist of same kind of atoms, can be converted into one another. See, white phosphorus is soluble in carbon disulfide, and red phosphorus is insoluble in carbon disulfide. Therefore, this is true, because this is not true, except they are asking. So this is untrue. The answer is option A. When white phosphorus is heated at 473 Kelvin under high pressure, what will happen? So this is a simple question. White phosphorus on heating at 473 Kelvin under high pressure, we get beta black phosphorus. So therefore, the answer is option B. We get beta black phosphorus. Next question. Which of the following phosphorus is more reactive? Red phosphorus, white phosphorus, scarlet phosphorus, violet phosphorus. White phosphorus is more reactive because of low ignition temperature. Since white phosphorus has low ignition temperature, it is more reactive. Hence, the answer is option B. Next is phosphine. The next compound is phosphine. Phosphine is prepared by the action of, it is a POC question, regular a 2-mark question. Phosphine is prepared by the action of. So white phosphorus on heating with sodium hydroxide solution. When white phosphorus is heated with sodium hydroxide solution, we get sodium dihydrogen phosphate. Sodium hydrogen phosphate or dihydrogen phosphate as a byproduct, and the product we get is phosphine. PH3 is a phosphine. So the answer is white phosphorus on heating it with sodium hydroxide solution. Hence, the answer is option B. Fill in the blank type questions are there in your board exam also. Calcium phosphide on heating with 6 moles of hydrochloric acid. 3 calcium and 6 chlorine reacts with each other to form calcium chloride. We have 2 phosphorus and 3 hydrogen. Therefore, we will have H3, PH3, phosphines formed. Phosphines formed. Now, white phosphorus on heating with sodium hydroxide solution. Again, here also we get phosphine. We just learned in the previous question. PH4I, when heated with potassium hydroxide, Ki is formed, water is formed. Again, this R is pH3 here. Therefore, PQ and R is nothing but pH3, and pH3 phosphine. Home signal, this is important question for your PUC as well as your comment. Home signal is this chemical compound. What is home signal? I told you in the ship, people travel in the night, so they will not be in a position to see the other ships moving around. Therefore, what they do is they take calcium carbide and calcium phosphide in a wooden container, and they are pierced it to form a small holes, and that is thrown in water. When it is thrown in water, they spontaneously get combusted to form, it gets what spontaneously burned or combusted, and that serves as a signal that is called as Holmes' signal. The answer for this question is option C. Now, this is with respect to phosphide. Now, chlorides of phosphorus we have to learn. We will learn with chlorides of phosphorus. The first one is a translucent white waxy solid A with excess of chlorine to give yellowish white powder B. This B, which reacts with organic compound containing OH group and converts them into chloro derivative. One is that, again, the B on hydrolysis gives C and finally converted to phosphoric acid. What is A, B, and C? The first one is white waxy solid as white phosphorus. This white phosphorus reacts with excess chlorine to form phosphorus pentachloride, PCl5, the first one. The second one is this PCl5, which is formed, reacts with the organic compound containing OH, that is alcohol, and to form chloro derivative, we will get chloroethane plus POCl3 plus HCl. Now, this PCl5, which is formed, this is B. This is A and this is B. Now, this B, which is formed, reacts or on hydrolysis gives you C. Now, what is the C? POCl3 plus 2HCl. So POCl3, this is C. Hence, the answer for this question is option C, P4, PCl5, and POCl3. Which of the following is not correctly matched? Which of the following is not? PCl5 is sp3d hybridized, PCl3 is sp hybridized, sp3 hybridized, PCl5 is solid, PCl5 is a brownish powder. So this is wrongly matched. PCl5 is not a brownish powder. Hence, the answer is option D. The next question, on reaction with chlorine, phosphorus forms 2 types of halides. On reaction with chlorine, phosphorus forms 2 types of halides, A and B. Halide A is yellowish white powder, but halide B is colorless oily liquid. What would be the hydrolysis product of A and B? So white phosphorus, P4, when it is reacted with excess chlorine, we get PCl5. This is A. Now, this white phosphorus, when it's treated with chlorine, minimum supply of chlorine, we get PCl3. This is B. Now, this PCl3 on hydrolysis, halide A is yellowish white, but halide B is colorless oily liquid. This is colorless oily liquid, which on hydrolysis gives A and B. So this on hydrolysis gives H3PO3. This is B, that is plus HCl. And this PCl5 on hydrolysis It gives H3PO4 plus 5 moles of HCl. This is A. The answer for this question is option A, H3PO4 and H3PO3. Oh, the next question. In the structure of PCl5, the axial bonds are longer than equatorial bond. So PCl5 is a triangular bipyramidal. So triangular bipyramidal. So this is a triangle, chlorine, chlorine, and chlorine. It's a triangle. Bipyramidal, one chlorine above the plane, the other chlorine below the plane. These are called as axial bonds, above and below the plane. These are called as equatorial bonds. Due to the repulsion between these two chlorine atoms, this axial bonds will be little longer compared to the equatorial bonds. Hence, the answer is option A. Axial bond pair suffers more repulsion compared to equatorial bonds. Now, this is oxo acids. You can just remember this. Try to remember these oxo acids. We'll work some of the questions based on oxo acids of phosphorus, and we'll wind up today. How many POP bond appears in cyclotrimetaphosphoric acid? Cyclotrimetaphosphoric acid has the structure like this. And here also we have the structure like this. So the number of POP bonds is POP1. This is POP2, and this is POP3. Totally, it has 3 POP bonds. Answer is option B. Phosphorus acid on heating phosphorus acid on heating gives the following products. That is H3PO3 on heating gives 3H3PO4 and pH3. The above reaction is an example for the oxidation state of phosphorus is +3 here. Oxidation of phosphorus will be +5 here, and the state of phosphorus is so from